Imagine a place far to the north, deep in Alaska's wilderness, where the land stretches endlessly, blanketed in snow and silence. Here, the air is crisp, the nights are long, and the only sounds are the whisper of the wind and the distant call of wild animals. It's a landscape that feels untouched by time, a place where nature reigns supreme and the sky seems impossibly vast. Above this frozen expanse, the aurora borealis dances overhead, painting the night with ribbons of green, purple, and red. The northern lights shimmer and swirl, a breathtaking natural phenomenon that has inspired wonder and awe for centuries. For the people who live here, the aurora is both a familiar companion and a reminder of the mysteries that lie beyond our world. But beneath these celestial lights stands something unexpected. A forest, not of trees, but of metal. Here, 180 towering antennas are arranged in a precise grid, each one reaching skyward as if trying to touch the aurora itself. This strange metallic grove stands in stark contrast to the wild beauty around it, a testament to human ingenuity and ambition. This is HAARP, the High-Frequency Active Auroral Research Program. From the outside, it might look like a scene from a science fiction movie, but it's very real. HAARP is a unique scientific facility, built with a singular purpose: to probe the secrets of the Earth's upper atmosphere, a region that remains one of the least understood frontiers of our planet. Located near the small town of Gakona, Alaska, HAARP was established in the 1990s as a collaboration between the U.S. Air Force, Navy, and several universities. Its remote location was chosen for a reason. Here, far from the interference of cities and civilization, scientists can study the ionosphere, the electrified layer of the atmosphere that plays a crucial role in radio communication, navigation, and even the behavior of the aurora itself. For some, HAARP is a symbol of human curiosity, a tool that allows us to unlock the secrets of the universe. Researchers come from around the world to use its powerful transmitters and sensitive instruments, hoping to answer questions about space weather, solar storms, and the invisible forces that shape our planet. But for others, HAARP is a source of suspicion and controversy. Its origins in military research, its remote location, and its ability to beam energy into the sky have fueled countless rumors and conspiracy theories. Some believe it can control the weather, disrupt communications, or even influence minds, a secret weapon hidden in plain sight. Is HAARP a marvel of modern science, pushing the boundaries of what we know about our planet? Or is it something more sinister, a project shrouded in secrecy and speculation? The truth, as always, is more complex than it seems. To understand HAARP, we need to look beyond the rumors and examine what really happens here. Inside its control rooms, scientists monitor data, run experiments, and seek answers to questions that have puzzled humanity for generations. We'll trace the origins of HAARP, from its early days as a Cold War project to its current role as a center for atmospheric research. We'll explore the science behind its powerful radio transmitters and how they interact with the ionosphere to reveal new insights about our world. And we'll dive into the wild and sometimes bizarre theories that HAARP has inspired, from weather control to mind manipulation and everything in between. Why has this remote facility captured the imagination of so many? And what does it say about our relationship with science and the unknown? Join us as we separate fact from fiction and venture into the heart of the HAARP story. In this remote corner of Alaska, the universe is waiting to reveal its secrets. And the answers may be more extraordinary than you ever imagined. To truly understand why HAARP was built, we need to journey back in time to the tense days of the Cold War, a period when the world was divided by ideology and the threat of global conflict loomed large. During this era, technological superiority was seen as a key advantage, and both superpowers invested heavily in research that could give them the upper hand. Reliable communication was absolutely vital for military operations, especially as the stakes grew higher. Armies, navies, and air forces depended on radio signals to coordinate movements, relay intelligence, and issue commands. But these signals didn't travel in a straight line. They had to pass through the ionosphere, a mysterious and unpredictable layer of charged particles high above Earth's surface. The ionosphere could bend, reflect, or even block radio waves, making communication a constant challenge. The sun's activity, especially solar flares and coronal mass ejections, could dramatically disrupt this layer. When the sun unleashed a burst of energy, it could trigger geomagnetic storms that not only blacked out radio communications, but also caused widespread power outages, damaged satellites, and even threatened the safety of astronauts in space. These solar storms were unpredictable and could strike with little warning, leaving military and civilian infrastructure vulnerable. Faced with these risks, the military recognized the urgent need to better understand and predict these disruptions. Analysts and scientists pored over data, trying to find patterns in the chaos of space weather. The ability to forecast ionospheric disturbances could mean the difference between mission success and failure, or even peace and war. Out of this necessity, HAARP was conceived, a unique facility designed to probe the secrets of the ionosphere. Unlike anything before it, HAARP could create small, controlled disturbances in this atmospheric layer, allowing scientists to observe how it responded in real time. This was a revolutionary step, offering a way to test theories and gather data that had previously been out of reach. The project was funded by the U.S. Air Force, the Navy, and DARPA, each bringing their own expertise and resources. Their shared goal was to advance our understanding of the ionosphere, not just for military advantage, but for the benefit of science and technology as a whole. By unlocking the mysteries of this region, they hope to improve everything from global communications to navigation systems that guide ships, planes, and even missiles. At HAARP, scientists tickled the ionosphere with carefully directed energy, then watched how it behaved. These experiments provided invaluable insights into how radio waves travel, how solar storms affect our planet, and how we might one day protect our technology from space weather. The data collected at HAARP has helped refine weather prediction models, improve GPS accuracy, and even contributed to our understanding of the auroras. In 2015, a new chapter began for HAARP. The facility was transferred to the University of Alaska Fairbanks, opening its doors to civilian researchers and fostering global collaboration. Scientists from around the world now come to HAARP to study the upper atmosphere, test new theories, and push the boundaries of what we know about our planet's connection to space. Today, HAARP's mission is pure science. It stands not as a secret weapon, but as a beacon of discovery, helping us unlock the secrets of the skies above and ensuring that the technologies we rely on every day remain safe and reliable, no matter what the sun may throw our way. High above the clouds lies the ionosphere, a thin, electrified region shaped by the sun's energy. Here, ultraviolet and X-ray radiation knock electrons loose, creating a sea of charged particles. This layer acts like a mirror for radio waves, bouncing signals across vast distances. But the ionosphere is dynamic, changing with the sun's cycles and dramatic solar events. Solar flares can send shockwaves through this region, disrupting communications on Earth. HAARP was built to study these changes, helping us understand how the sun and Earth interact. Our reliance on satellites and radio makes this research crucial. By probing the ionosphere, HAARP helps protect the technology we depend on every day. How does HAARP talk to the sky? It's a powerful radio transmitter sending focused beams of energy into the ionosphere. These waves heat a tiny patch of the upper atmosphere, just a few degrees for a few minutes. The effect is local and temporary, dwarfed by the sun's constant energy. Scientists use this brief disturbance to study how the ionosphere reacts. They measure changes in radio signals, observe faint airglow, and even create weak artificial auroras. Each experiment is a question. The ionosphere's response is the answer. This controlled approach lets researchers unravel the mysteries of a region otherwise out of reach. Grand scientific projects often attract wild stories, and HAARP is no exception. Built in a remote location with military funding, HAARP quickly became the focus of conspiracy theories. Books like Angels Don't Play This HAARP claimed it was a secret weapon, not a research tool. Theories spread online, fueled by distrust and the facility's futuristic appearance. Photos of the antenna array looked ominous, and the science was hard to explain. In the absence of clear information, speculation flourished. The idea of a weather-controlling superweapon was simply more thrilling than the reality of plasma physics. The most persistent myth is that HAARP can control the weather. Some claim it manipulates the jet stream, steers storms, or even triggers earthquakes. Photos of unusual clouds are cited as proof of HAARP's power. In this narrative, natural disasters become acts of human engineering. These theories offer simple explanations for complex events, turning HAARP into a convenient villain. Scientists have repeatedly debunked these claims. HAARP's energy output is tiny compared to the forces driving weather and earthquakes. The ionosphere and the troposphere, the layer where weather happens, are separate systems. HAARP's radio waves don't reach the ground, let alone tectonic plates. The energy needed to move the Earth is millions of times greater than HAARP could ever produce. The facility now welcomes public tours and shares information openly, countering myths with facts. Let's compare myth and reality. Myth: HAARP is a secret weather weapon. Fact: its energy is minuscule and can't affect weather systems. Myth: HAARP triggers earthquakes. Fact: its radio waves don't penetrate the ground or influence tectonic plates. Myth: strange clouds are HAARP's doing. Fact: these are natural formations unrelated to HAARP. The evidence is clear. HAARP is a research tool, not a doomsday device. When people hear about HAARP, the High-Frequency Active Auroral Research Program, they often wonder, is it a secret weapon, or is it a marvel of scientific achievement? The truth is far less sinister and far more fascinating than the rumors suggest. HAARP is not a weapon, but a one-of-a-kind research facility designed to unlock the mysteries of the upper atmosphere. Its powerful antennas send radio waves into the ionosphere, allowing scientists to study how this region of space affects everything from satellite communications to GPS navigation, and even the auroras that dance across polar skies. Despite the wild stories and conspiracy theories, the scientific evidence is overwhelming. HAARP's experiments are open, published, and reviewed by experts around the world. The myths simply don't hold up to scrutiny. Instead, what we find is a community of researchers dedicated to understanding our planet's natural processes. The real power of HAARP lies not in destruction, but in discovery. By probing the ionosphere, HAARP helps us understand how solar storms impact our technology, how energy moves through Earth's atmosphere, and how our planet interacts with the sun's ever-changing activity. Unfortunately, misinformation about HAARP spreads quickly online, eroding public trust in science and distracting us from the real challenges we face, like climate change, space weather, and the need for better global communication systems. In reality, HAARP is part of humanity's timeless quest for knowledge. It's like a giant telescope, not for looking at distant stars, but for peering into the invisible layers of our own atmosphere, an unexplored frontier that holds secrets vital to our future. Rather than something to fear, HAARP is a symbol of international cooperation and scientific curiosity. It brings together experts from around the world united by a desire to learn more about our planet and protect the technologies we rely on every day. The universe is vast and complex, and our curiosity is what drives us to explore it. Every question we answer leads to new mysteries, and every discovery brings us closer to understanding our place in the cosmos. Facilities like HAARP are essential tools that help us see our world and our connection to the universe a little more clearly. By embracing science and discovery, we move forward together, guided by curiosity and the hope of a brighter future.